I'm going to work through some examples of function operations. The important thing to think about and remember with function operations is that you already know the math. All we're doing is adding the formal notation so that rather than being given the problem as like a combine the like terms or add these polynomials, you have to take and substitute the functions or the polynomials that we're working with. So number one is asking us to add f and g. So the other thing is knowing that you have multiple ways to write this notation that mean the same thing. So f plus g inside of these parentheses is telling us to add those two functions. So we can take and write them separately, and then we substitute. So f of x is x squared plus 3x minus 5, and then we add g of x, which is 2x squared plus x minus 9. So hopefully in this form, this looks familiar to you and something that you've done before, because you would have been given this type of problem and then told to simplify, which is just combining like terms. So we would have 1x squared plus 2x squared is 3x squared, 3x plus x is 4x, and negative 5 plus negative 9 is negative 14. And that would be my final answer. Same thing for f minus g. All they're asking us to do is subtract those two. And so we would have the same two expressions. The difference would be that we have a subtraction sign in the middle rather than addition. And if you remember from adding and subtracting polynomials, we do need to be careful here because I'm subtracting everything in parentheses. So you need to think about like distributing the negative 1 so that this becomes a plus and everything changes. Or remember your integer rules, and so we would be subtracting negatives, which would change to a positive. So there's lots of different ways that you might think about it. I typically just say, well, I don't want it to be subtraction. I'm going to add that and then distribute the negative, which means the sign of everything behind it changes because it's like distributing the negative 1. And then we combine like terms. X squared minus 2x squared is negative x squared. 3x and a negative x is a 2x. And a negative 5 and a negative 9 is again going to be a negative 14. Also remember with subtraction, it's not commutative. So you can't take and subtract g of x and f of x and get the same as f minus g. So we're going to do the second subtraction, substitute in g of x, substitute f of x, and then I'm going to make this an addition and change the signs and combine like terms. So 2x squared minus x squared is x squared. X minus 3x is a negative 2x. And again, we have a negative 14 at the end. So if you see here, all those signs are different. So it's not the same thing. Addition is commutative, subtraction is not. Number 4, we have this closed sign, which is our multiplication. So they're asking us to multiply the function g by the function f. In Math 1, you would have taken and used a distributive property. So you might, use boxes and the box method and things like that and combine like terms. For right now, I'm going to leave my answer like this. It's the same. I'm multiplying those two things together, but now I don't have to worry about making any small mistakes, careless errors. So I'm not going to multiply those together, but you need to know that that is what you could do with those two things. And then for number 5 and 6, we have division. So you see here we have two different notations that mean the same thing. They're division. But we see in number 5, we're putting f in the numerator and we're putting g in the denominator. And what we've created here when we do this is a rational function. And we're going to study rational functions in an entire unit because there are some problems with denominators. My denominator can never be equal to 0 because I can't divide by 0. And so for right now, we're just going to say that we know that there are going to be values that need to be excluded. And I'm going to teach you later how to identify those. For right now, I just would like for you to be comfortable with this notation and know what it's asking you to do. So for 6g is going to be in the numerator, so we're really just creating the reciprocal of number 5 and showing that we would divide those two functions. So that's how to read and think about the notation and then go through the process of solving. The last operation that we need to learn is composition of functions, and we looked at an example of this in our warm-up the other day. So it's the process of combining two or more functions to create a new function, and we're going to substitute an entire function into another function. The notation is written two different ways. So we can have g and then inside parentheses f of x, because remember, this is the input. So this tells me that I'm inputting f into the function g. We can also write the notation as g of f of x. So that's how we read this, both of these, g of f of x. One thing you want to note here is that when we have our function operations, like I said, I have trouble talking and writing at the same time. If it's an open circle. So students often confuse composition and multiplication, especially because in this first notation, you're used to multiplying when you see parentheses. That's kind of been drilled into your head since you were in middle school math. So it's really important to know that function notation here, this is not multiplication of those two functions. It's inputting one into the other. So the open circle tells us that it's composition. And again, it's important to think about we're working from the inside out. So we always start with the innermost set of parentheses and then work our way to the outside. So we might actually be finding a number value to plug into the other function, or sometimes we might be writing it as another function rule. It depends on, again, what you see in the problems. So number 7, h of g of 2. Another way to write this looks like this, and that's what you see in number 8, something similar. So again, we start at the inside. So this tells me I'm taking 2 and I'm plugging it into g. So I would evaluate g of 2. So I'm plugging in a 2 in place of all of the x values. Cancel. So g of 2 is 4. So now that output becomes the input into function h. So I substituted because those two things are equivalent. And now we're going to take and evaluate function h with a 4. So I take the function rule, I substitute the 4 in place of all of the x's, and I get a single output. So again, for number 8, excuse me, I start at the inside. I find f of negative 10, so I'm plugging in negative 10 for all of the x values in function f, and negative 10 plus 7 is negative 3. And now that output becomes the input. I'm using h, so again, I'm using those letters in the front to tell me which function rule that I'm using. I'm replacing the x's with -3. And that would be the final answer. So those are evaluating for number answers. We can also evaluate and find function rules. So meaning we're going to have the variables, and I'll scroll back up because I need to be able to see the functions. So again, we're working from the inside out. So this is telling me that I'm taking h of g of x. I think I have one extra parentheses in there. So h of g of x, I'm taking g of x and I'm plugging that into h. So I'm going to replace g of x with its function rule. And now this is what I'm taking and I'm plugging into h. And remember, function notation tells me that I'm taking the function h and replacing its x value with this input. So everywhere that I would have an x, that entire expression gets substituted in for the x. Because that says I'm taking all of the outputs of that function and creating a whole new function. And then we're going to simplify. So I'm going to distribute the 4. And then the last thing would be to combine like terms. And the only thing I have here is 24 and -1, which would be 23. So if I took every single output of g, and plugged them into h, I would get this quadratic function at the end. In number 10, they're asking me to take h and plug it into g. So this is the same notation. I tend to like this one better just because it helps me see what's getting plugged in. So I'm taking h of x and plugging it into g. So again, I'm going to take g, which is x squared minus 3x plus 6. And for every single one of those x's, it's going to be replaced by this entire expression. So when we use the same variables, they can get a little confusing because I have an x, but I'm putting in another x. So sometimes seeing those boxes can help. So we would take 4x minus 1 and square it 3 times, and then that x becomes that entire expression, 4x minus 1 and plus 6. Now, you could multiply all of that out if you would like. I'm not going to because that's a lot of unnecessary work. So that is the final composition for that expression. We can compose multiple times. So number 11 is asking us to take f and compose it into g, and then take all of that and compose it into h. So that's why I said it's important to start at the inside and work out. So we're going to start, we're taking f and plugging it into g. So let's do that here. So again, g is x squared minus 3x plus 6. And then I need to take f, which is x plus 7, and put that in all of these x values. So we'd have x plus 7 squared minus 3 times x plus 7 plus 6. So all of that is going to go into h. H is 4x minus 1. And so all of this goes here in place of that 1 value. And again, we do not need to waste time simplifying. I'm confident that you know how to do that. Yeah, you may want to like put brackets around it and then minus 1. So that, all of that is our final answer.